I'm all nervous now.
Do you need graph paper?
No, I don't think so. Okay, we'll see as we go on. Okay, so this is section 2.3, Extrema and in behavior. And we're going to discuss mostly in behavior. And I'm going to do that by looking at some graphs that we're going to be looking at in the future. And this is something you'll use in Algebra 2, so it might be something that you're trying to get a hold of very quickly. So I'm just going to create a graph, and I'm just making this up out of my head. I'm just going to maybe do something like this. Okay? And this is a graph. This is a nonlinear graph. What does that mean?
It's not a line.
It's not a line. So it's not, and this works for linear graphs also, and I'll talk about those in a minute. But I want to talk about this. First of all, I want to look at some things that are just normal graph things. Okay, the first thing I want to look at is that we have basically in this graph, we have 3 points that touch the x-axis. Okay, do you know what those are called? They're called x-intercepts. They're called x-intercepts. Okay, and we have 3. And just to give you an idea, they are ordered pairs. So Utan, what would be maybe the first one's ordered pair? You'd have to guess.
What? Gas, you said?
Yeah, you'd have to guess, because it's not right on a line, is it?
Oh, so like, is it like 5 point?
Yeah, it's negative 5 point, okay, negative 5.5 and then 0, right?
Yeah.
Okay, this one might be a negative 1, 0, right? And this one might be 1, 2, 3, 4, 5.30. Okay, all right. So then you have this point also, which is an interest of concern. What is that?
Y-intercept.
That's a y-intercept.
That's where you spin it.
Okay? And we only have one, and it looks like it's about 0, 1, correct?
Yeah.
Okay. So what axis is this? This is the x-axis. All the values that are above the x-axis are positive. And all the values that are below the x-axis are negative. Okay? Now, let's take a look at this graph. As it's coming, this is going this way, right?
Yep.
All right? And what do these values do in the y values? Are they increasing or decreasing?
Decreasing.
Decreasing. At what point do they start increasing?
Like negative 2, or
So this point, approximately right there.
yeah.
Okay, at this point, they start to increase. Okay, this is what we call an extrema. Extrema is a point that is either lower or higher than the points around it. Okay, this one happens to be a relative minimum point. It's a relative minimum point because all of the points that are near to it are above it. Does that make sense to you? All right. There's one more up here because when we start increasing, right? And then we get up here and there's one more right here. And so that is called a relative maximum. We call it relative max for short. Okay? And it means that all the points that are around it are lower than it. Yes, sir.
What about like the relative minimum?
Uh-huh.
So that arrow is still going down. So would that be it?
The relative minimum is right exactly where the points are decreasing turn into the points that are increasing. There's that point that just stops, which is at the bottom of the trough.
Okay.
Okay? All right. Do we understand everything on that? Okay. So the extrema are the places that are higher and lower than the places around it. Now we do have an absolute max and an absolute min. We do not have in this case because our arrows go on, right? Speaking of our arrows, we are going to talk about this and this right now. And this is where we get what we call, and I'm going to change markers, this is what we get what we call end behavior. I'm going to run into my relative max. the end behavior. We have two sides of this graph that have end behavior, the left side and the right side. What I'm about to show you is how you write mathematically what's going on. Okay, now as this graph goes, it is still going like this, all the way out, right? If you watch my marker, I'm sorry, it's going all the way out, right? That means that the x values are continuing to go this way, correct? And how far do they go? Infinite. So we would say the end behavior is as x approaches, and see that arrow? That means it approaches. A negative infinity. Why do we have to say a negative infinity? Because it's going negative. CJ, do you understand it?
Yep.
Okay, so as x approaches,
The arrow on the right one's going to right?
this one right here is the one we're talking about. As the x
To
value,
the left and right.
as the x values, Utan, are going this way.
Okay.
Does that make sense to you?
Yeah.
Okay, so as the x values are going this way, what are the y values doing?
Or they're going big.
They're going up, aren't they?
Positive.
They're going up. And they're going up to infinity, aren't they? Okay, so what's a fancy way to write y?
F of X.
F of x, thank you. F of x is approaching positive infinity.
Why do they put F of X?
Because we deal with functions, bro, and they want you to get used to function notation. Does that make sense to you? Okay, that's about the only reason. Okay? Any questions that far? All right, so let's go over here to this side. And I can write it underneath here, I can write it over here, but I'll write it underneath here so you understand it's on this side. Okay? Now, on this, the x's, we're going out, aren't we? And what are we approaching? We're approaching positive infinity. So as x is approaching positive infinity, the good thing about positive infinity is we don't have to put anything. It's just infinity, right? As we approach infinity, what does f of x do? It approaches negative infinity. Do you see that? Okay? Any questions about that? All right. So you don't have any questions? I'm going to erase. Okay? All right. So let's talk about a different one. Let's talk about this guy right here. You've seen him before. He's a parabola.
Is that one we just did considered a parabola?
No, that is a cube. X cube value. Whoops. I got a little wild here. Can you just go with that? I got a little crooked on that right side. Okay. All right. First of all, this is a parabola. All right. And this guy has symmetry. And we've not talked about symmetry. But it has a line symmetry where a line goes right down here. And if we were to fold it, it would be right on it, right? We actually talked about line symmetry yesterday. I think I said we've not talked about it, but we have. Okay. So you understand that it has line symmetry. It does not have point symmetry, but it does have line symmetry. We good?
Yeah.
Okay, it has one extreme value. And that is this one right here. And it is actually not a relative minimum, it is an absolute minimum. Because it is definitely the smallest on the graph, right? Okay, so what I want you to do now is I want you to discuss that in behavior as the way that we did on the last one. Okay? So how do we begin?
F of X.
Is X?
No, X.
As
X
x
approaches.
on the left side.
What's that?
As x
Okay.
approaches
Positive infinity.
negative infinity, because we're going this way, right? F of x approaches
Positive.
It's going up.
positive infinity.
But it's to the left, though.
So that's how it's always going to be?
No,
X is
I'll show you one of those.
X is left and right, Y is up and down.
Okay, now let's go up here. This one. As x approaches what?
Positive.
Positive infinity. F of x, it approaches positive infinity also. Now, I think I brushed you off too quickly, Carly. Carly asked, is it always going to be that way? You are always going to begin this way and this way. You're always going to say x is approaching the left side, what's y doing? And x is approaching the right side, what's y doing? So those two are always going to be the same, Carly. Is that what you meant? Okay, I apologize then. Yes, that is true. Okay? All right, now Carly says, is it always that way? Well, we can do a lot of things. For example, we can do this. I can just make different graphs. Okay. Now, let's take a look at this one. This actually has symmetry, probably this line right here, right?
Yes.
Okay. If I was to draw it normal, if I was to draw it the way I wanted to draw it, it would be that way. It has this, which is called what?
Relative max.
Relative max, and this one's called a relative min, and this one's called a.
Relative max.
Would that be absolute max?
Actually, those two would be absolute max.
Yeah.
And I meant them to be at the same place, and they're not. I get that, but they would be, yes. Okay, if this one was a little lower, this would be a relative max, and this would be an absolute max. Right? Okay. What I want you to do is I want you to write the extrema then. Harper, are you okay?
Yep.
Okay. What I want you to do is write the end behavior then of those. Okay, on the left side, would you give me what you have, Harper?
X approach, as x approaches negative infinity, f of x approaches positive infinity.
This approaches positive infinity?
No, negative.
Negative. Okay, I agree with that. Now, Bo, what's the next one?
As x approaches infinity, f of x approaches infinity.
F of x approaches what?
Infinity.
Negative infinity, isn't it?
Oh, yeah, that's right.
Okay, all right. Does that make sense to you too?
Yes.
Okay, all right, would you turn then to page 108? And let's look at number 9. I'm gonna try to draw number 9.
It's on the assignment.
Yes, it is on the assignment.
Where are we doing the assignment, like on paper?
Yeah, we're gonna try. I might do some things differently, but let's start out on paper. Is that okay?
Yep.
It's on regular paper, not on. Okay. Okay, this looks like number 9, correct?
Sure.
Okay. And it says, use the graph to describe the end behavior of each linear function. Okay? Would you, first of all, is that a linear function?
Yeah.
Why?
It's
It's
not
not.
a line.
It's a straight line, okay? All right, so what I want you to do is I want you to write the end behavior for the left and the right, please.
Do we have to like label left and right?
No,
You always start with the
no.
left.
Yeah, I mean, if you put the left on top, the right on bottom,
Right.
I'll be able to figure it out because it tells you what the instructions are. Addie, will you tell me the left?
As x approaches negative infinity, f of x approaches infinity.
Okay? You agree?
Yes.
All right, and then the right, Carly.
As x approaches infinity, f of x approaches negative infinity.
like that?
Mm-hmm.
Okay, so let's just go through number 10 then. We'll just keep on rolling.
Do you want us to write these down?
Yes, please.
So do we have to do like one of them then, or do we have to do both of them?
You have to do both of them. In behavior is always however many ends you have. So Dawson, how about number 10?
As x approaches the negative infinity, f of x is negative 2, because it doesn't go any lower than
It approaches infinity though.
Okay,
Going right to
Well,
left.
that,
it doesn't go down any.
all right, let's talk. Okay, I'm gonna double check something, because this book sometimes says it differently, so, well, actually, not this book, but some of them say it differently. This is 2, 3, right?
Yeah.
Okay, this is number what?
10.
10.
And you said as x approaches negative infinity, f of x approaches a negative 2.
Yeah.
F of x approaches a negative 2.
We put them both.
Okay, so what happens as x approaches positive infinity? F of x approaches
Positive 2.
negative 2. It's still at a negative 2.
Yeah.
Okay?
Yeah.
Does that make sense?
Yeah.
All right, let's do 11. Who haven't I talked to? CJ, have you done one?
No, I haven't.
Okay, let's do number 11.
As x approaches negative infinity, y approaches negative infinity.
Okay, prefer that you say f of x approaches negative 2,
Okay.
but, yep. And then on the positive side, or the other side,
As x approaches infinity, f of x approaches infinity.
all right, very good. All right. You know, I'm gonna change this. I think you guys got the Extrema pretty good. I'm gonna change this to page 108, 9 through 14. So you just have 3 more problems to do. Addie, would you text Jaws and Greeley and tell them to watch the video, and then do 9 through 14 if you would, please.